So here are the answers to the practice quiz of Chapter 8. The figure below shows a family of cost curves for a firm. The subscripts 1, 2, and 3 for the short-run average total cost curves refer to different plant sizes. Refer to figure 8.3. Each of the three SRATC curves shows what? So even without looking at this question, we have to understand how all of this works. In this chapter, we've seen that the long-run average cost curve is an envelope to different short-run average cost curves. We cannot go through it. It always has to be the lowest point. And what the long-run average cost curve represents is the lowest cost per unit achievable at different output levels. This is the cost per unit, not total cost, but the cost per unit at different output levels that you can achieve. But if we look at different plant sizes, we're not always at that lowest point. And if we look over here for producing, let's say, Q2, it is cheaper to have this plant size than to have this plant size. Why? Well, at this smaller plant size, we're getting really high costs to producing more because we have a very crowded kitchen. We're not very productive. Whereas in a larger plant size, we may have greater fixed costs, more space to pay for, but all our workers are more efficient. Therefore, our cost per unit may be lower. And if I were to expand on this one here and keep going through, I'd see for that quantity 2, it'd be very expensive because I'd have so much wasted resources by having too big of a space. So we have that kind of situation here that we're looking at. So for each of the three SRAT curves, if we look at the whole SRAT curve, we're not just looking at the lowest cost attainable. Where it touches, that's the lowest cost attainable for this quantity 1, quantity 3, and quantity 5. But the whole curve doesn't just represent the lowest cost attainable, given that the plant size is the largest it could possibly be. This is the lowest cost attainable for different output levels for this plant size here. The lowest cost attainable holding the plant size constant. So one SRAT curve holds the plant size as constant. So yes, it is the lowest cost it could get for different output levels. Optimal plant sizes in the long run, it doesn't tell us that, other than the lowest points tell us that if you're just tangent to this LRAC curve for this output level, this would be the plant size that is the cheapest, so that's not the answer. Technically inefficient methods of production, given that they lie above the LRAC, is false. The output that is possible when all factors of production are fixed, that is also false. So it's really the lowest cost attainable holding the plant size constant, because the thing is here with a short-run average total cost curve, is we're looking at maybe like 800 square feet, 1200, 1600 square feet, whereas the LRAC looks at all possible sizes at the same time. These ones only look at the lowest costs that you can find for a specific plant size. All right. So refer to figure 8.1. Which of the four firms in the figure is displaying decreasing returns to scale at all output levels? So if we go back to this other figure here, we would often separate this LRAC curve into three segments. One downward sloping segment, if I disregard all the SRATCs. One segment that was flat. This one's not really clean on that. And one upward sloping segment. We refer to the first part as increasing returns to scale or economies of scale, constant returns to scale, and then diseconomies of scale or decreasing returns to scale. So here we're asking about decreasing returns to scale, not increasing returns to scale. So it has to be an upward sloping part. This section here has downward and upward sloping. It's not the right answer because here they're saying at all output levels. So the only one that represents this is firm C. In the long run, the law of diminishing marginal returns, what happens to it? Well, if we think about the short run from the previous chapter, the law of diminishing marginal returns would happen when you had an overcrowded kitchen. If you add one extra worker, his returns, even though he could be a complete clone to the worker you hired previously, are going to be smaller because he's going to have access to less and less ovens, counter space, whatever to do his job. So it's going to be less and less productive. So the returns on that extra worker will be smaller and smaller and smaller. But that is because we have a fixed kitchen space. In the long run, we don't have a fixed kitchen space. Therefore, the law of diminishing marginal return does not hold not because technology is variable. It does not hold because we don't have a fixed space. It's exactly the same as in the short run. It's false because we don't have that problem anymore. It does hold regardless of production processes is false. It's not relevant because there are no fixed factors of production. That is true. This law of diminishing marginal returns is not relevant because there are no fixed factors of production. We can change the size, the space, the amount of ovens, and everything else in the long run. Sometimes holds, depending on the production processes, is false. In defining a firm's long-run average cost curve, the time period must be longer than 1 year. Long run and short run are not defined by a specific time frame. They're defined based on certain attributes. We know that in the short run, certain factors of production, which may be the number of machinery we have, the number of space we have in our factory, the number of different things has to be seen as fixed. In the long run, all the factors of production are variable. And they represent altogether, they're drawn within the long run average cost curve. So factor prices are held constant and technology is assumed to change. That is false. Even though that over time we assume technology to change, we see this long run as being, we have absolute flexibility on all factors of production. But if technology triples over this, like in 2 years' time, that LRAC curve will not be at the same place. The cost per unit will not be at the same place if ever we have like this massive boost in technology. So technology is assumed to be fixed. And if we were to change it, the LRAC curve would have to move. Technology, factor prices, and the quantity of factors of production are all varied. That's false. Technology cannot vary. Otherwise, the LRAC curve would not be at the same space. It'd be one different one for every technology levels. Factor prices are held constant, and the quantity of factors of production used is varied. So yes, those price of the workers, price of the factory, price of everything else is seen as fixed, because otherwise it'd be too complicated if you allow it to vary. The LRAC curve could take many different shapes. If you assume that a square footage costs this amount or twice the amount, well, the LRAC curve will obviously not be at the same place. Factor prices are varied, and the quantity of factor production is held constant. Well, actually, no, it's the quantity of factors of production that is variable. When a firm seeks to minimize costs of producing a given level of output, it does not need to know what. So in chapter 7 and 8, verses 9, 10, and 11, is we're really focusing on the cost side of things. There was this production part that was also important in chapter 7 to figure out how the cost curves would be set up. But we're really looking at production and costs. We're not looking at profits yet. We're just looking at how can we produce goods cheaply. So in that first diagram we have here, we're not looking at what's the price of the good right now. We're just looking at, if I were to produce different output levels, how cheap can I produce it on average per unit? That's all we're looking at. So when a firm seeks to minimize costs of producing a good, it does not need to know the available alternative methods of production. That's false, because that has an impact on how much you could produce goods for if you could produce it in a different way. The cost of production, of the factors of production it uses, well, the people they hire, the machinery they use, they need to know how much it costs. It's production function, that relationship between hiring more people or using more capital to produce more. They need to understand that relationship. The level of output that maximizes its profits. We don't know anything about profits at this stage or price. So this one, we don't need to know this. How its costs change as its production's methods change, we need to know this as well. So we don't know about maximizing profits yet because we don't know the price and revenue side of things yet. So that's the piece of information that we don't need to know to evaluate the cost side of things. Hopefully that clarifies the answers to the practice quiz of Chapter 8. Thanks.